Welcome to 𝗟𝗡𝗡𝗪 episode 129. My name is Connor, host of 𝗟𝗡𝗡𝗪, and today with us we have two panelists. The panel has grown, folks, by 50%. I guess we will go around and do brief introductions. We'll start with Adam, and then we'll finish with Madeline.
Right, so I'm 𝗦𝗛𝗡𝗆𝗪. I am the head of language design at Dialog, and I've been doing APL for a long time.
And over to you, Madeline.
I'm Madeline Regani. I am the creator of 𝗡𝗢𝗧𝗘𝗦. That's probably how you know me, if you do. And I've been doing that for about 4 years now.
Awesome. We're happy to have you today. We mentioned, I think it was a couple months ago now, I think it was back in June, and technically we're beginning of August, that we were looking to grow the panel. And so we are in the phase where we are going to be bringing on guest panelists for the next little while. And we are very excited to have Madeline as our first guest panelist. And I guess I usually say, as mentioned before, my name is Connor, host of 𝗟𝗡𝗪, massive fan of all the array languages. And with that, let me know if my audio is too loud, because every single time it's too quiet, but now I see the mic going super red. So I might have to adjust this. But while I do that, we will throw it over to Adam, who I believe has two announcements for our episode today.
Yeah, so the first one is at the APL Forge, which is this annual thing that Dialog has going, where people can submit projects that they've been doing in Dialog APL or for Dialog APL. Has concluded a round. Next one has started. You can always submit ideas, look at forge.dialog.com. But the point is here that the winners for this year have been announced. So there is something that might be known on the podcast here. But Karl Krokin with his voxel game, and our very own Kalle Högstra with his array box. So that's the one thing. The other thing has a little bit to do with Madeline, or a lot to do with Madeline. Oh yeah, congratulations, Connor.
Look at that. Look at that.
For the audio listeners, there are now celebratory things, icons floating up over the screen, courtesy of Madeline.
It's courtesy of me. I'm doing it myself.
I think it's Connor.
You're doing this. Oh, okay.
I didn't know how to do that.
I wasn't sure I was going to be able to get this to work on a Google Meet.
Okay,
on
on my screen it's showing up on Madeline's face. I don't know why.
Oh.
Right. The other thing has something to do with Madeline, actually. So Madeline has been she got this grant from the APL Trust to work on the APL 387 fund, and I happened to notice that APL 64, which is the new offering from the traditional vendor of APL Plus, it now ships with the very latest version, just came out. It now ships with APL 387 bundled. So that's pretty cool that they've sort of picked that up without anybody from our side telling them about it. Like to have them part of the community a little bit. It's just a corner. Dialog APL also ships with APL 387 next latest version, every new build. But, that is cool to see.
Interesting. So it is pervasively. I'm trying to think actually too on my site, the one that won for the contest. Plug.
Favorites.
I don't even remember the shortcut, but I know Control H is for the help, and then.
Yeah, you do use APL 387 as well on the font there.
I think it changes within the languages.
Yeah. If you go Control B, it shows the fonts per language. So 387 is used for APL Cap and 𝗡𝗢𝗪. J uses JetBrains Mono. 𝗦𝗛𝗢 uses 𝗦𝗛𝗢 386, and BQN uses BQN 386. So half of the languages on array.
But it could be more. You could switch BQN to use APL 387 as well. It now has full coverage for BQN, I believe, and 𝗦𝗛𝗢 support is in progress, or at least scheduled, planned to happen as well. So you could actually go universally. J, of course, doesn't care because it's just ASCII. Yeah. Of course, it covers ASCII.
Right.
We're aiming for APL 387 to become the universal array or Iversonian array language font that can handle every Iversonian array language.
Awesome. Well, I'm not sure if there's a link for that, but if there is, Adam will send it to me after the show, and I will put it in the YouTube description / show notes on the website arraycast.com. And I think with those two announcements out of the way, we are going to... we didn't actually officially decide. Are we doing a little problem solving today in multiple languages? Or are we going to pivot and then call an audible at the last second live on YouTube to a different topic? What say the panel?
I mean, I think we can start with a little problem solving, see where it takes us, discussions of things.
Okay. We didn't discuss this either, folks. This is all happening live. Who's screen sharing? Is it going to be Adam? Although, because Adam's got the laptop with the issues, or the computer with the issues. Is it better if Madeline screen shares? What should we do?
Well, let's look at the problem before we volunteer.
Well, we can't look if no one screen shares. But I mean, technically, I can drag it over our faces if we want. But I can read the problem. Although now I don't actually know. It's on my left monitor. So we're going to be looking at this week's challenge, which just dropped in the last 12 hours if you're listening to this live, and plus however many hours if you're not listening to it live. And we're going to skip task 1 of challenge 385 from Perl Weekly Challenge and go to task 2, which is a twist on a classic APL problem. So I'll hover it over my... Ooh, that's over the whole screen now. I'll hover it over my face, and you can see our 2 other beautiful panelists, but not me. And it's called Outermost parentheses. You're given a valid parentheses string, and it's asked to write a script to return the string after removing the outermost parentheses of every primitive string in the primitive decomposition of the given string. So if you're an audio-only listener, you'll have to pay attention to what is a primitive decomposition. But if you're watching this on YouTube, you probably, just by looking at the examples, have already deduced what a primitive decomposition is. But basically, it is for any valid substring of that string. Well, I guess it has to start left to right. So, because you could technically take an inner parentheses if you're not starting from left to right. But if you start from left to right, and each time you can take a substring from that point that is a standalone valid set of parentheses, then like that's your first component or chunk of your primitive decomposition. And then you just recursively do that. So for the first example, it's left paren, right paren, left paren, right paren, left paren, right paren. So that decomposes into just 3 sets of left and right parens. And so the result of that example is an empty string, because if you just have 3 pairs and you remove the outer parens, you're left with nothing. And then I don't think we need to go into the other examples, but if you're watching on YouTube, there's a couple other example 2, 3, and 4. So that is
the sentences they only consist of parentheses, right?
Yes, it's
Yes.
guaranteed to be valid. You don't need to do a validity check up front.
Yeah. Okay. So that it is actually an interesting problem, because this you can solve in multiple ways that I can think of.
Perfect.
Immediately.
A little inside baseball. Adam said, it's not too interesting before, because everybody knows how to do this, because it dates all the way back. Was it the notation as a tool of thought? Does it come up in this paper, or it comes up in a paper that is like decades old, that Iverson shows the outer product solution? I can't remember which paper it is. Maybe someone in the chat. Although now I've lost my access to the chat. But yes, this is what we will be solving.
That's a classic sort of problem, at least. But there are some interesting approaches, because we're not interested in the actual level of parentheses. We're only interested in what remains when we remove all those parentheses. That means I'll start with a sort of a cheating solution. Let me share my screen.
Oh yeah, I just thought of a neat trick as well for solving it.
Yeah.
That avoids partitioning.
Yeah. Well,
I wonder if that actually works. That would be crazy if it works. I don't want to spoil it for the listener right now, but I'm thinking of. Should one of us? Oh, here we got the screen share. So we're getting rid of the problem description. Actually, here I'll link it. We never link these problem descriptions. It's linked in the YouTube live comments. And now Adam is screen sharing. And should we do something? The classic. Well, actually, what is the classic or naive way you would solve this? I don't know. Maybe there's not even agreement on that.
No, I think the classic, it's not naive, but like the classic thing is to look at the parenthesis level. Right? And then, so every time we have an open parenthesis, we can like increase that level that starts from 0 by 1. And every time we're closing parenthesis, we can decrease it by 1. This gives us, for every character, the ones that are like the level that they're at. Now I don't remember exactly how it was. Like there can be other text, right? Because we want to return what's there, right? So this we want. Sorry, I'm using an experimental interpreter that's going to give me errors all over the place. So that's going to be fun. 1 second. I can do better. As you did mention that I'm the one that's using the laptop that has issues, and APLs that have issues. Sorry. I should be there very soon. Let's close this one down, if I can. Or let it crash if it can't close, or just, I think it can close. Okay, brand new one. Ladies and gentlemen, this is where you saw it first. This is dialog version 22. And
weren't we on 21? You're telling me the 22 is going to have less issues than the 21?
No, it's just that my installation of, we're using experimental 21 for something that somebody was working on. It's as an issue. Okay, so I just wanted to confirm something because you don't have the problem description of it, right? So this should return ABC, right? And even this should return ABC, if I understand right. But it's easier to see what we're doing. And so we can see what the correspondence is between these numbers, and then we can do a subtraction vertically. So for each parenthesis that's opening, right, we're subtracting 1 minus 0 or 0 minus 1. So that gives us positive and negative numbers. So that gives us the change for in the parenthesis level. And if we then do a running sum, then we get the parenthesis level. Of course, it's slightly offset because we say that the opening paren is part of the new inner parenthesis, but the closing paren is not. But we can adjust for that. And so we can see that when we have an opening paren that's a 1, we remove it. We have a closing paren that's a 0 that needs to be removed. So this is actually enough. We don't even have to do any further adjustments. So we could here say this is the depth, and then we can say if P is equal to an open paren and the depth is equal to 1, or a bit more parentheses for clarity here. Or if T is a closing paren and the depth is a 0, right? So this is our depth, and these are the parentheses that we want to eliminate. That means if we negate this, hitting the wrong buttons, that gives us a mask for the original text. Right? So if we stick that into the mask, and then we can do the mask and replicate on the text, and that we got what we wanted. So this is one way we could do it. We could also adjust directly these numbers by some rotations so that we get a a 0 in those positions. We can try doing that. So if we go back for a moment, so let's start with this one again. We've got D here, which is the level. We also have our original masks over here. So really what we want is that if there is a 1 in the bottom and there's a 1 in the depth, right? Or there's a 1 on top and that's the opening, right? So this means open. This means opening, these two together, and this means closing, and this is the depth. So here we've got open, close, open, close. So if you have a 0 over here, and we've got a 1 down here, or if you've got a 1 up here and a 0 down here, right, and the level is 1, then those are the ones we want to eliminate. So so we can say if we could match that, right? If we want a function where only 1, 0 on top to the bottom gives 1, and we want 0 at the top and 1 at the bottom to give 0, and then we want to eliminate them. So we can do some mathematics here. If you want exactly this one pointed out, that's where we could just set to the top row. It's actually easier. So we have the depth. Sorry, I'm just sort of moving around here between them. Go do the depth. That's this one. And we also have the top and the bottom rows from these two. So if we split up the comparison to these two, and we say this is opening and this is closing. Okay. We can even stack them on top of each other. That's the same matrix. But now we have them as separate vectors. That makes it a little bit easier to deal with them in this case. Then if we got opening and the depth equals 1, and that's the same thing as I did before, and then we can say, or we have closing and the depth equals 0, or nor, right? Because that's we want the mask. There we go, and then we can take T like that. Well, can't really do it won't have the same length, but we can put this as our mask, and then we can say mask. This is a fairly clean way of writing it as 3 statements without having to do like a new comparison of. We just do this as the minimum number of comparisons that we have.
Well, surely you don't need to check for closing since you know just the negation of the other one.
When you should have to have to look for closing?
Well, C is just not O.
Yeah, that's true. You're right. This is a more general one, right? This will work even if you have additional text in there. It's like so inadvertently did that. So yeah, you're right. We can combine them like this, which means we could combine them like this, and which is the same. And then we have by the way a comment in the chat that is saying they didn't know you could evaluate inside array notation to this degree where you can set it inside and next cells can use the result. And so every value expression inside array notation is just normal APL expressions. So whatever side effects happen there, they just happen, so you can use them later. However, we don't even need to assign O here because we can use C over here, and then we can just say, because we know it's Boolean, instead of and, we can just say that it's less than. Right? This less than is actually the same thing as not left and yes right. So we don't need to set that. Oh, did I make a mistake? Oh, because the depth, I forgot to set the depth. Oh, that's right. So we do need both. I forgot to say d gets plus backslash open minus closed. There you go. Yeah. So this only prints the openings, not the closings. And then we can get rid of that for now. The depth and mask and result we have over here. Can we combine this further? I can't really think of a good way to do it.
Well, what does this look tacitly? Because you got 1, 2, 3 assignments.
Yeah, it's not going to be very nice tacitly. It can obviously be done, but we can try it, but it's not going to be beautiful. So if you want to make it a function, yeah, first let's make this a proper function. So we don't want to return these things. We just want to compute them. This. And like that. Okay, so this one is explicit. Okay. And let's try to make this tacit, but it's not, as again, it's not going to be nice. So we'll start by this mask over here. So we combine that, and then we also eventually we need we can actually do this as a giant behind, because we're going to compute a mask, and then we're going to apply it to the original argument. So we're going to have some giant function over here, and it's going to be really nasty. So let's space this out to help readability just a tiny little bit. And for this, we need to find the two C and O. So one of them is going to be the original, and the other one is going to be the nut. And then we're going to subtract them from each other. That's over here to get the D, and then we do the running sum. So now we're up to D over here. The problem is that we don't just want D and continued computation. We also want back references to O and C as per the formula over here. So we're going to glue these two together and have a function that's between these two, which, by the way, this can also be a behind, but we can get back to that as we have a right tag here and a nut over here. But we'll get to that. Okay, so this is D, and we now have there's going to be some repetition here, which is not going to be very nice. So we want to where 1 equals, so taking the left part first, and O is on the left. That's the negated one. So we want the left argument and 1 equals D. So this is the left side of the NOR over here. And the right side of the NOR is going to be exactly the same. We might be able to simplify this a little bit. And then we're just going to have 0 here, like that. So I think this is all we need. If I haven't made any mistakes, we can try it. It didn't even work properly because I made some mistake somewhere.
I think I need to write that on the second.
Oh, it's this one. Yeah, it should be right there. Yeah. There we go. Okay. But I mean, you don't want to write this tacitly. And we're doing computation twice. So we could potentially avoid the computation, but avoid computing this twice by merging together these two somehow, but it's not going to be very nice. We could eliminate this outer function here by doing something like, yeah, it's not going to be nice either. I think we can beat this. Nasty. All of it is nasty. We can move the negation in here on both of them. that eliminates the outer thing here. What's the chance I'm going to get my parenthesis right at this point? Okay, don't need this anymore. We can just put it inside. Okay, and then we need to apply this both sides here. And the right argument is that one, and the negation is that one. This might work. Yeah, it still works. Oh, I guess I'm doing this symbolic, like, manipulation in my head, at least, of the APL code, but I wouldn't exactly call this nice. It condenses a bit. Can you read this, Connor?
Well, the thing that I'm thinking in my head is like, does it? Because like I have a solution, but it's just the outer product, subtraction, column-wise scan, or column-wise reduce plus scan, and then I just add the equals right paren to it.
Yeah, you can do that as well. That's the other part, the other approach to that. Getting.
I was thinking,
or go ahead,
if you
Madeline.
do -1 rotate on D and you take the minimum of D and -1 rotate, it gives you zeros where either opening and closing. Yeah.
You can do that as well because we know that it's well formed. So let's try this.
And for the listener, D is the result of the plus scan on either the solution that Adam's built here, where you're storing the opening and closing parens and just doing subtraction, or the outer product column-wise subtraction.
Yeah. So we have D already, the depth, and if you do a 1, actually it doesn't.
-1, I think.
-1 rotate, we want another 1 rotate here. So it's okay. I need to stack T on top, so we can even put D. How do you know what the next thing is going to be?
If either is a 0, you have to remove it. So you just take the minimum or multiplication or whatever of D and the rotating version.
Really?
Yeah, because you have zeros where it's closing, and if you shift them, it's gonna be in the next opening, which definitely is gonna be the next one.
Oh, because of the constraints, right? Again, I'm thinking, like, what are the other characters? But it can't be. So you know that if we're hitting a 0, the next thing after the 0 has to be a 1. There are no other options. That's true. That's cute. So if there's a 0 in one of these, which actually we can we can actually cheat a little bit, because we can look at, I mean, there are different ways to do it. We can compare them with 0, right? But we could actually also just multiply them.
I was thinking a sign of times.
And take the sign of that, yeah. So that's a mathematical approach, right? If you multiply them, then we get this, and then the sign is the mask, and then we can filter with that. So we do, and this will turn out nicer in a little bit in tacit at least. Yeah. So if we go, so again, minus vertical reduction on open close. I mean, even though this outer product is actually not really good because we're doing more comparison than we really need to, but okay, fair enough. This is D, and then we can write in a nice tacit fashion. So we can write -1, and then the argument times the rotation.
You're missing
the plus. And then we can do the sign there. So we can take this whole function, but of course it doesn't work well tacit, totally tacit. But if you do it as addition here, then we can write it like this. That's what I need. That's nice. I didn't think of that.
Wait, because we...
This will not work if there were other characters in there. It will only work.
I know, but why do you need the I mean, I guess you need the defund because you need to...
It's because of these monadic functions. That we can totally do it tacitly, but it's just going to be really, really ugly. Because we need to apply this monadic function. So we need to parenthesize. We can't bind it with a top, but we don't have nothing either from BQN and for J cap. So we have to parenthesize it. And they use a lot of mutability, in my opinion, when you do this. But yeah, this works.
I
think there are... what do you say?
Oh, no, it is a couple characters shorter, I was going to say. Than my previous solution. That's a neat trick, the rotate.
Yeah.
Seems like this would be well, it's hard to tell without actually trying it, but in cap you'd have only 2 trains. So you don't need the parens, and then you also have an outer product glyph.
So wait, there's something else I want to try here. So we still have to go through the depth. But if we do the depth here, and we can put T on top, right? So it's more readable. So a 1 is what we want to get. We want to get rid of the ones that are 1 and open. No, I was thinking whether we could look at the pattern that we've got. This is what we want to eliminate. Okay. I think I have an idea. We can look for this pattern of 0, 1. Right? Those are the ones that are above a 0, 1 are the ones we want to eliminate. So let's say we do it like this. I'm going to replace it with this array notation inside a function, so we can give a single parameter. Let's say we do a 1 rotate of this. Okay. Now it's it doesn't really matter. Now it's the -1, 0. We can also rotate the other way around, and it's going to be the same -1, 0. Okay? And anywhere we have -1, 0, that's what we want to eliminate. So if we look for this pattern, we can also do it after we do the running. So we can do 1 here, and now so what happened now? We rotated the first character to the end. Is that we should do that 1 rotate here, so otherwise it's hard to understand what's going on. So we take the first character, move to the end, and that means that we're pairing that one, the opening, with a closing from here. So now what we want to eliminate are the characters that are above the 0, 1. So we've got one here, we've got one here, and we've got one over here. Okay, so if we can start by doing it with find, because it's easy to spot what's going on. So this gives us a mask where we've got 0, 1. And what we want is the next character after that as well. So we can do a 1 rotate on that. Oh, sorry. Did I make a mistake here? Oh, duh. I put it in the wrong place. 1 rotate. Over here. That points at the next character.
It's a -1 rotate.
Oh, -1 rotate, right. -1 rotate points at the next character. So one of those two. So if we do combine them again, so we make this little train, this or the rotate. those are the characters that we want to eliminate, which means the nor on that are the ones we want to keep. And it doesn't matter that we rotated the initial character to the end, because the initial character will always be eliminated. There's no other way. So now we can do this whole thing like this. And we have to well, it's rotated the step, so we have to rotate. We either rotate the mask or we can rotate the input over here. So like that. Is it shorter? No. Sort of a different way of doing things. And this we can change this whole thing to use a pairwise instead. So we can say we're looking for that, and then we rotate it right and left. So we do want to put a 0 in front or behind. So this. Is that not right, what I'm doing? Oh no, because these are actual numbers. Yeah, we can do that. We have to look for the pattern of 0, 1. Yeah. It's not a Boolean.
All right.
But this works. Yeah. I still think there's a better way to do this.
Well, I posted in the chat the cap equivalent of the last solution, which is very nice. Here, I'm blocking your screen now. You have to go to the YouTube live stream to see this. But it's just nice because, like I said, it has the outer product primitive, and
the array with primitive that binds together. Yeah.
Yeah. So.
But I'm not sure. I mean, what we're doing here is this thing. In cap, I would guess you can write that differently. Let me try it. I have it over here. So I'm now showing my Rebux. I don't know exactly what's on the stream. So because of the way things bind, I would think that we can. How is it in cap to write a scalar character? You write like an @ sign in front, I think.
Yes.
Yeah.
So if we do @open paren equals. No, we're not allowed to do that, right? I wanted to do something like this. But that's a fork.
Oh, but you can just do like equal to the closing one, and then you do like.
Oh, and the not. Yeah.
Yeah, not before subtract or something like that.
Right. So if we do equal to, if you do this, and then we do the not subtracted from that. What if this would work? Oh, it already evaluates, right?
No, if you hit enter.
It gives the same result, so I guess.
Yeah.
Yes.
I guess I should put some little confetti every single time you hit enter.
Yeah. I see. Following what's happening here. So we're taking the closing paren and comparing with the whole string. Then we're taking the negation of that and subtracting the original value. That's what behind does, and then we do the running sum. I think that's nicer than the outer product.
It is, although I have to say the @ is an eyesore.
Yeah.
But other than that,
BQN's way of writing it like this.
Yeah. I mean, I do like the two. I do like the two characters. I just like the @ is not very APL fontish, you know.
For a character, no.
Or
It could have been like a
symbolically, like it's using the right font, but it doesn't. Although you could argue that a couple of these, like the fork syntax in cap, is a little.
Uh, um, yeah, back to something. Oh, wait a minute. I think in BQN, you don't need to do this at all because, or if you 1 second, if you've got affine characters, these two are one off from each other, right?
Ooh.
So you can actually just subtract adjacent characters, and go from there.
Unfortunately,
I
you
think
don't
Cap has
have
those as well.
pairwise.
No, you can't have everything, right?
Yes, you can. You just go straight to Tiny Apple.
The Tiny Apple has affine characters as well.
Yeah, of course.
Of course, of course. And if it's
But I
if
think
it, if
Cap
it's
has
missing
as well.
something, you just switch to it.
Okay, Madeline, do you want to drive? You want to share your
Sure.
screen?
Yeah. Okay.
Also, Marble Coma in the chat says they solved this earlier today. If you've got a link and you want to drop it in the chat, we can show your 𝗦𝗛𝗡 solutions if you want. It's kind of putting you on the spot, but
Okay, so we want to just do the pairwise subtraction. Okay.
Yeah, so this
Oh,
now
but
we
this
can
does
see.
right.
You know that it's -1 are the ones in the area we want to eliminate.
Oh,
right?
because it's right. So you just do this. No. I don't think that's right, Max. It's just telling us the difference between them. Is that useful?
Yeah, because think about it, the ones we want to eliminate, except for the edges, right? We know that we want to drop. Oh yeah, we could have done that. We could have done like a one drop, -1 drop as well, because you know
Oh,
the
yeah.
person that character must be removed. So the ones we want to get rid of are the ones where you got 1 -1, right? No, what is this? This is
No.
it can be
This is just
that can exist though nested in a
yeah, exactly.
primitive component. So I don't think that actually works, right? I'm pretty sure actually one of the
oh
examples
yeah, it
has
shows
that.
you have to go. Yeah, you have to go do the scan, of course. Yeah. It doesn't help.
Because we don't really care about the difference between like what do affine characters actually give you? Like you
No,
still
you're
have
right.
to compare. Yeah.
If you do a scan on that,
This one is the scan. This one, the second one is the sun scan.
yeah.
I don't think it's.
No, we still can't tell what level it's
Yeah.
at. Oh. There might be some way to do this using the differences, but
Yeah.
well, one thing you can certainly do instead of comparison with the parentheses, you can just subtract 40, right?
Oh yeah.
Or something, or subtract the character before. And what is 39? It's a quote. It's going to be awkward.
Yeah, but I don't think it's that much better. It's probably clearer to just write the comparison.
Yeah, it's not even shorter.
Yeah.
I'm sure there's some regex way to do this with some balanced pairs thing.
Probably, yeah. I'm trying to think. It seems like there should be a way to do it without the whole depth, but I'm not sure. Because it gives you a lot of information that you don't need.
Yeah, that's what bothers me.
Should we look at 𝗦𝗛𝗀𝗆𝗪's solutions
Yeah,
and then see if we're inspired to find a way to avoid the depth? I guess.
Okay. What's their poster?
They said they created a GitHub discussion. I believe that's probably on the ArrayCast site.
I don't know if I opened it. I don't think I have. No.
Yeah, it does.
Okay.
Oh, admittedly, it's not loading on my computer. Well, it loaded for you, so. So yeah, we're on part 2. Which is...
Okay.
Okay, so this is the same thing exactly we had, right?
Yes.
The add open paren, do a negation and subtraction. It's just choosing which character you do. Then doing what's the plus thing doing? The second plus.
It's a plus
This one?
scan.
This one
Oh, that's a plus scan. But what's the other
This
plus?
It's adding the original. I think it's Connor's. It's adding because this one keeps around the original mask, and then it gets added to some skin.
Yeah. Okay.
And then just replicate. Yeah. I think it's like the ones where they have essentially.
I still think there's a better way to do this.
This one could be the side. Source. Oh, because it's greater than one. Why greater? They're not greater than equal. Oh, because it's, okay. Yeah, it makes sense. Right.
Yeah, 𝗦𝗛𝗀𝗆𝗪 in the chat says, didn't see the start of the stream, but I'm not surprised that it's the same because it's a pretty natural solution. To be honest, though, like if I were not as array-brained as I am now, like the functional way to solve this, coming from like Haskell land, is to do like a split and then a drop, first, drop last, and then a recombination.
How do you choose what to split on? The depth?
Yeah, you'd have to do that as well. But like Haskell and functional languages, to my knowledge, don't really have. I mean, I guess you could do like a filter after a zip with the depth if you wanted to, but like that's not where my functional brain would go to first. Especially in Haskell when you have words and unwords, like you're very used to this kind of, splitting and recombining pattern. I don't know. I guess you'd have to ask actually, Madeline, you're a Haskell programmer.
I think it would just do a fold.
You would just do a fold?
Yeah.
After zipping with the depth, or
no,
I guess you just do a
the depth is a state and the result, and just add if it's not 0.
Really? That's that's your Haskell brain. That's not like your array brain.
Yes.
Oh, I have a fun solution then.
Oh, this is fantastic. This is wait. Let's do this Haskell thing first. This is the first time ever for Arraycast, episode 129, folks. If you're live on YouTube, you know what's happening. But if you're an audio listener, you're confused. We are at play.haskell.org. Didn't even know it existed, folks. Back in 2018/19, when I was a Haskell fan, I don't think this existed back then. Or if it did, I didn't know about it. And so we're watching live coded Haskell. We got monads, even though you might not know they're there, folks. And
what, monadic functions?
Nope. Well, yeah. Clash of the Monads. That's what we should do, an episode called Clash of the Monads. Although I guess it's kind of, they're very simple on the APL side of things.
So I was thinking so we started that with 0, and then, so if it's the x1, that means, okay, so you have 0 and whatever, axis and something. We need to just do the same thing, but increment. So, like this. Yeah, and so that's pretty, and then 0. Now we can't 0 degrees, so I guess it doesn't really matter. Then we have and it says and closing one. Then no, it's 1 and closing is going to be 0 and the same string, and everything else is that was I'm not sure it's going to work. Yeah, okay. Million errors. Oh, I think I have to. Yeah. This is different time ago. Now it's worse. Oh, we gotta change this. No. Match. Expression. I think we can hear Adam's one and let's come back later with the working Haskell solution.
Sure, I can share my screen. I've come up with a couple of interesting developments over here. Experimenting, so
we'll be the judge of that.
See?
Maybe not, if the screen never shares.
Give it a moment. It's just has to hang a little bit here. Okay, so a couple of things that I started exploring. One was let's look at that first. Let's look at the depth vector that I've been working on. So we did it before with like saying the closing paren and then not behind minus and that. Oh, sorry, get rid of this. It's just nice and short. Another thing that's nice and symmetrical is if we do like open paren or close paren, doesn't matter. So equality, that's all the open parens, and inequality, that's all the closed parens. So we can write that as a nice fork, like that. Equality minus the inequality. I thought that's sort of neat. Either way, once we have the depth vector, we can go back to this one. Then I did it with partitioning. So here's the depth vector, and if we then look at at the pattern here, then we can see if we can split every time there's a 0, and then every section begins with open and closed paren that need to be eliminated. We can actually eliminate the closing one by exploiting the APL2 partition function, because it starts a new segment whenever we increase the value, and it discards anything that has a 0. So if we switch to the magnitude here, then we can see the pieces that we're going to get. So now we can use this to partition T. And all we need to do now is drop the first from each one and merge.
Oh, drop the first from each one.
Yeah, because that's the opening paren that never got eliminated. The closing one got eliminated by the partitioning having hit 0. So we can write all of this together as a tacit function even if you want, because this is just behind this whole thing here. But there's a lot of monadic functions going on. So we can write as a definition to begin with here, and yeah. So this is a valid function. Right? Here's a single monadic function. There's a dyadic function, an array, and a monadic function. So that's valid. That's the trick. We can also write this. There's a lot of monadic function application going on. But if we go back to what I did before with the equal minus unequal, that comes out nicely as a dyadic function. We still have to do a right tech here or bind. We can stick the plus scan on top of the minus, and the result of the whole thing we can put the sign. So this gives us this. Now we have a fork in here with the left argument and the right argument. So another fork. We can bind the left argument instead. Being that that's a derived function, this whole thing a single derived function, not a train. We don't need parentheses over here either. So now we have a fully tacit solution that is as short as the hybrid tacit explicit one. Which I think is the shortest we've got so far in the APL. Is it very readable? Maybe not, but I don't think it works. So this is partition the argument by where we have the sign of the equality with open paren minus the inequality with open paren, and we've done this sum scan of that. Then drop the first of each and recombine.
What are all the different ways now we've spelt the depth vector?
So we've got the outer product.
Yeah, so the outer product.
Completely split up one, right? So we can say, so depth outer is open close paren jot dot equals the right argument.
Yeah.
We got depth separate. We would just say open paren minus close paren, which we can make that look nice if we put it's nice and palindromic, sort of like that. We have done it with a negation or like a not. So we just look at the close paren in APL because we only have a one hook operator. We use the close paren for that. We could actually use the open paren and not equal as well. Doesn't really matter. Not behind minus. So this isn't even the whole depth, right? This is only getting the this onto the subtraction. So this is missing, I think. There we go. Now these are all equivalent here. Yeah. And do we have another way to do it? Well, then
Well, you
there are
just
different
had your
formulations for
little
this.
equal, not equal fork.
Yeah, but it's the same. Okay, sure. So d fork, if you want, which is open paren equal minus unequal. Ooh, here's another one we can do.
Can you do
Something.
1 minus 2 times? I think that works.
1 minus 2 times the right side, you mean?
1 minus 2 times closing equals.
Yeah. That's just a mathematical way of expressing the same thing. 1 minus is a not.
Oh, right, so just the same one as the not. Yeah, yeah.
But yeah, I mean, that's valid. But I just realized now that everywhere we've been doing open paren, that's sort of not very elegant because we know the first character is an open paren. So we can actually write it in a neater fashion. If, for example, this one, so let's say we have t, we know that the first character t is open paren. So we can write first unequal to the whole thing, which is a behind. Look at this behind here. Okay. And then we do the not behind minus on that.
Yeah, that's really nice.
No constants involved. And it works for all types of brackets now. That's nice. And then we do the scan and so on. I like that better. I really want the last primitive because in this one here, it'll be nice to do first equals minus the last equals. But of course, we could just write first unequals if you want. So this is another way to do it. All looks sort of symmetrical, but this needs parentheses. There are many ways of spelling things. But these do too many comparisons. This should be the fastest. This or with a constant, it doesn't matter. Because a Boolean negation and the mask, that's going to be very fast. So I think I prefer this. So that's one part of the problem, is get to the depth vector. So far, we haven't come up with any good solutions that doesn't need the depth vector. Or any solutions that don't need the depth vector.
I have the Haskell one if you want.
Yeah, you want to show it?
Yeah. I just forgot how types work, but it doesn't matter. Sure. Okay. So yeah, it's just basically fold. You keep around the current depth and the result as a state, and then you just fold over the string. And so if it's 0 and it's opening, then you want to increase the depth, but not add anything to the string. If it's 1 and it's closing, you want to decrease it and not do anything. Otherwise, you just add and increase and decrease based on what it is. Then you just pick out the string and you reverse it because you append it instead of prepend instead of appending because it's faster, and then you just print it. You can probably do it with a right fold as well. It's probably better. You can just do this. So you don't need to reverse because you're just bending it the other way. That's better. But yeah, it's not a good solution, but I think this is how I will approach it. I think this works as well. No. Whatever. No, because I have to reverse opening and closing, I think. This way. But Well, I don't think it would look good in any array language. Servers. Well, yeah. I mean, so you could. I mean, I can try writing something. I don't think it's gonna be. So then I want to make a font. Something with string. Let's just make a define, I think. So, but I want to check if it's.
You might not want to do it use a fold. You might want to use loop over all the elements instead. It's easier.
What do you mean?
You're just carrying the state, right?
Yeah.
So you can just have a state variable. But, yeah.
Well, but I don't already have a way to do loops so that I don't fold in. I guess you could use an until, but it's not gonna look good, I think. No, there's no good way to just make a loop. I guess that's good. And then let's bring more lines up on some idea. Then if it's 1 and closing, then we will return 0 and if it's whatever, and so this, oh, this I can make it size simple, I guess. Then I guess just return the first plus I guess -1 to the power of omega equals closing. And the other one is going to be omega second of snake. I think this works. Did it. What is minus space? No, I don't know. But yeah, and it's definitely not going to be pretty. I don't know what I did wrong, but just appending always, right? Yeah, I don't know, but yeah, definitely worse than the array ones. But I don't think there's a good way to spell the array ones in Haskell. So I think people usually just make this fold. Maybe with a Boolean, like checking for equality first, maybe I would do that. So the function is total. But other than that, yeah, I don't think there's a better way.
I'm working on some state machine thing. I can show you, but there's again not going to be. It's not a APL,
yeah,
but it's more general purpose thing you can do. Let's see. The computer gets around to sharing. So here we set up a initial state and a result accumulator, and then we do our use the fork here. I'm passing in the open paren, and this is the whole array. So this each is actually looping over the left argument.
all right.
And just passing that in. So if the equal minus unequal, that's the what we did before, and then we're testing the state. So if the state is 0, we should say omega here. If the current state and the current character is 0 and open paren, then we want to eliminate it. right? So which means if they, so this is eliminate. I'm just gonna write it for now. And the other case is if the state, oh, it's not, it's a1 here. And if the state and the left argument is a 0 and a closing paren, that's where we should write this out. It's going to be silly to do it like this. You know what it is. Okay, so the state and the current character is 1 and open paren, we want to eliminate it. If the state is and the current character is a 0 and a closing paren, we want to eliminate it. So now we can say if this is a member of one of these two, then we want to eliminate it. Which means we can take this and we can firstly use it behind there just for good order. Which means if one of those is true, we want to drop from the current character that we're dealing with. And I think we don't even need to update an accumulator there because this just gives the bunch of these empty vectors and nuts. Now we just enlist that. So that works. I suppose that's sort of philosophically speaking the same thing as you're doing in Nesta, even though here I'm carrying an outer state, so I'm muting this. But yeah. So I suppose we could do this. Yeah, we could do this as a reduction. It's going to be the same thing, but it's just going to be more complicated to keep track of things. Also, this is completely unreadable. But actually, we can state some logic, right? If it's if it's a 1 and open paren, a 0 and close paren, that's the same thing as saying that it's equal to the open paren, right? No, because it's
no, because you have
it's not a Boolean. Yeah. We could separate this out and say if D is less than or equal to 1.
You could probably do the index of D in 1, 0 is equal to the index of omega in open close. No, because that no, I think that's good.
Oh, but we could say this, right? We only want to eliminate it if D is less than or equal to 0.
Yeah.
And we also want to eliminate it. The other criteria is that we can. It doesn't really work, right? Oh, right. The other criteria is that B equals. This is fun. Omega equals open paren.
Okay.
That's fun.
And then the point is you don't need them less than or equal to 1, because then it's definitely going to be false because these.
Yeah, if D is true, right, it can't be true, right?
Yeah, exactly.
So it has to be. That's the only case. So there we go. That's nice. Which means there's only one D left. Yeah. Well, we have that. Yeah. That's nice. We could do something very unusual. We could do an equal reduction. That it's not shorter, but it's cute. And this one we can go back to what we had before. That'd be shorter. Oh, did you make a mistake? Has to be a closing paren. Or unequal.
Yeah, or you put the negation on the other side, but then you need the self.
You need a self down, like yeah. So this is a real state machine. Right? This is the state, the depth. We're updating the depth as we go along using one of our many methods of doing this. And then we do this. But I mean, this drop thing is a bit cheating. Like, really, what we should do here is we should say we should collect instead. Either we can have an accumulator, so we'll put that in here, and then we say r comma gets that. Then we don't need to do the in list. That's a more general solution. Or we can get the mask out. So we just want to find out what the mask is here. So, and add to the mask. But these are the ones we want. This is the opposite because of the equality here. That's fine. We could flip it or not, or we can do some clever things here. So I think we have to do like this. There you go. And now we can use the mask. That's a state and sort of accumulator.
Yeah, I mean, you don't really need we just
no, I mean, we did.
Yeah. You just return the Boolean from the each.
Oh yeah. Of course, we have that here. Gosh, silly me. So this gives us the Boolean, and we could just do that. We don't need to stress that in at all. Which means we can do it behind.
Yeah, I mean, it's not good, but it's neat, I guess.
Yeah. Yeah, it's going to have horrible performance.
Oh, yeah,
now I'm thinking instead of initializing D like this and having like nested, what if can we do this? Can we store a state? We start with a state of 0, and we use a function that lives inside here, and we update D as we go along. That works.
Yeah, sure.
But you can only use the function once, so you have to reset it.
All right. Well, no, it cannot be 0 at the end, is it not? If the string is valid.
Oh. Yeah, yeah, you're right. It happens to be that it works. Yeah, so we can actually use this. Yeah, it resets itself when it's done. Very nice of it to do that. Connor, you following how this works? This is using lots of interesting features, should I say?
Not really. Go ahead and.
We lost Connor. Okay, so this is a behind, right? Where we are. It's a classic by now, or oft repeated pattern by me, where we have a function that computes a mask, and then we're using that to filter. So filter by this function. Now this function, which is here, well, actually the whole function is here, but we're going to apply it to each character. And the function lives inside a namespace that at definition time had a single member D that is 0. So it's an object, right? A state. But this state is not observable outside of F. There's no way to access it whatsoever other than like doing a memory dump. So like that, looking at what's in memory of the computer. So this function operates inside this namespace. So when it refers to D, it's the D that's inside this namespace. And it mutates that. So we're using our formula from before to update the state. This is the same. This effectively for every character gives us the running sum of the subtraction of the outer product. And that like we did before. But we only interested for every character in the state at that point. So we update the state for this character, and then we do this little bit of clever thing here. I can expand this again. D is different from this equals to this. All right, so then we say this is the current character an open paren. Then we want to keep it only if the current state, so that's a 1, only if the current state is not a 1. Because those a 1 with an open paren, that's what we want to eliminate. And if it's this highlighted part here, if the right argument, the current character is a closed paren, like this gives 0, then we only want to keep it if the current state is not 0. Because if you have a closed paren at state 0, at depth 0, then that's an outer 1, and we want to eliminate that. So this gives us a Boolean mask for every character, whether or not we want to keep it. And as Madeline correctly pointed out, we know that everything is well balanced in the string, which means that when we reach the very last character, which will be a closing paren and will be eliminated, and then the depth state is back to 0. So we always increase the nesting depth and go back again to 0, which means that the function is ready for the next invocation. Now, if you run 2 of these in parallel, then they might get mixed up because they have the same state. I'm not sure if we can induce that, but maybe. I think so. I think we can actually force that to happen. So if we do like T and we'll make another one. T2, like this. And then we can do, if you run F in the background on T, that should print. Yeah, and F in the background of T2, that's fine. So if you run it on both, oh, sorry, that still works because it does the whole run. But if we redefine this to insert a delay of like 1/10 of a second or something, then they could possibly get out of sync. I think, yeah, now we get a messed up result because they stump on each other's state. Statefulness is bad.
This reminds me of the quote, "Just because you can doesn't mean you should."
No, that's absolutely right. This is not how you're supposed to do it in an array language. But there are things that are not easily done with it just by computing vectors and going on. Sometimes you do need to compute a state as you go along, and then this is sort of a general method to do that. I'm not sure you should do it with an namespace, but what we did before, we set it up and we set some states and some accumulators and so on. It could also be like classification things, and it depends on what you've seen in the current state. This is a general way to do it in array language. It's not really horrible to read. It does require mutating states of these semi-global variables, but that's, yeah, lexically scoped, it works fine.
All right, last thing while we wind down, you should take a look at the caps. I converted your dialog APL solution to a cap solution using 3 different behinds. The links in the bottom of the YouTube chat.
That's this one coming up over here.
Oh, look at that emoji rendering. What?
That's the old one, I think.
That's the old one.
That's the old one? There's a new one?
There's a new one.
Oh, it looks the chat didn't update for me. Maybe I haven't been seeing people's comments and things because I don't see anything since you wrote cap is very beautiful.
Here, I can message and mess up our live stream, the chat, and then you can click on it there.
Or you can just share.
I could, but that would risk.
Okay. So it's coming. It's on the way. It's in cyberspace. No message just yet. There you go.
Oh yeah. I was gonna say, I guess I could have just read to you the 4-character hash code.
Yes. But so this is the one.
Yeah.
It
Well,
hasn't
No.
it hasn't updated because there's something about the URLs because it looks like an ID. It tries to jump to that heading, so I think I have to put it like a new window for it to work. That might be a deficiency in the design of ArrayBox.
is that really how it works?
Because you're using a hash there instead of just using a slash or some other character, and you're using it to read, then you can't switch it when you're already on the page. The browser thinks, oh, you just want to jump to a different location in the same document. That's what they do.
Wow, that emoji rendering is so aggressive compared to my emoji rendering. I think mine's the iPhone soft. Yours is like the Microsoft.
It depends on the
3D,
operating system and the browser and so on.
Well, here actually, this is the beauty of I can drag and drop my little thing, so people, that's my emoji, which is much cuter than the Microsoft 3D one. Anyways, this is the.
You just need to add emojis to 37, I think.
Sorry.
What is it?
You just have to add emojis to APL 37.
Yeah. Well, do we agree on which rendering though? It's probably
No. Then if we were to do that, then they. The what?
We just compose them of little.
Yeah.
APL.
Okay. If it was, then they should be like line drawing art, not like.
Honestly, it's obviously you were joking when you said that, but there's actually something behind using APL glyphs to render, like, you got 4 different glyphs to render the different, you couldn't do all of them. It'd be too much work, but you could do a few. Anyways, this is, yes, the dialog APL converted to cap, which is a little confusing because they switch up some of the symbols on you, so it makes it a little bit harder to read.
Yeah, so this is the petitioning thing.
If you hit F1, it's beautiful, beautiful. Look at that, folks. Look at that.
Petition, right? So it uses the APL2 pairing of glyphs.
Mm-hmm.
So, and this is first, right? That's just for the same reason as an APL2. We could make it look the same in dialog if we wanted. So yeah, this is exactly the same, right?
Yeah.
It's literally just no. Oh, this is tail, right?
Yeah.
Yeah, I thought it was called behead, but I think it's only called behead
J.
in
it's
J.
not in the ducks.
No, I think it's confused because your cursor is to the left of each, but if you just put it to, I don't know, that is actually a bug. That should be highlighting drop first.
Yeah. Yeah, okay, drop first.
Although, interesting. Actually, let's diagnose this bug. Put your cursor to the right and then shift left, and maybe that's what it is. So it reads the cursor.
Yeah, that's what I did. That's really wrong. It forgets to look at the direction of the selection or something. But anyway, if something is selected, it should go by the selection. Don't care about
it's supposed to work that way. I don't know what it's doing. I'll file a bug on my own repo. And
you didn't write the code, right?
No one needs to write the code any day anymore. We're all just handcrafting APL code now. But the rest of it, if it's JavaScript, send it to the AI.
So having drop first does the trick here.
Yeah, that's what I was also thinking. I wasn't going to code this one up, but then I was like, oh, wait, doesn't cap have behead?
Do you have that in TinyAPL? Yeah.
No.
Ooh,
Oh, no.
A missing primitive. The people demand all the primitives in TinyApple.
Even J has behead.
Yeah. Well, I thought that's the other one, which is nicer. The -1 drop. I use that one more than 1 drop.
Curtail. Yeah, curtail.
Yeah.
It's
Interesting.
Very cute names in J.
Here's a last question too. I think it's a Google share. I was gonna say there was like a slight phantom help doc that I could see, but I think it was the screen sharing software, not actually the website. Anyways, all right. this has
We
been
done?
this has been fun. Thanks to 𝗦𝗛𝗀𝗪. My chat's gone. Oh, there it is. Thanks to 𝗦𝗪𝗀𝗪 for sharing their 𝗦𝗧 solutions, and thanks to Madeline for coming on and showing us not only TinyApple but also Haskell. Like I said, a first, folks. That's why we need to grow the panel so we can get more functional languages on this array programming podcast. Any last things to be said? To be done? If not, going once, going twice. With that, we will say happy array programming.
Programming.